Hi everybody, we're going to do a quick lesson here on factorials. So we have talked slightly about what a factorial is. We really never defined it, and so I'm going to go ahead and define it here and work through a couple examples. When I'm done with this, you guys will have a worksheet. There's a front and a back, and you guys can work through those together. So let's go ahead and get started. So the first thing is what does n factorial mean? So n factorial is for n times n minus 1 times n minus 2 times n minus 3 times ... all the way down till you see 3, 2, 1. Now, if n is only 3, then we would start at 3, 2, 1. But this would just kind of imply that n is greater than that number. And it's the product of all numbers, all whole numbers less than n. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. And we can do the multiplication, so 20 times 6. This has a value of 120. Now, a few of these factorials you will remember. For example, 2 factorial is 2. 3 factorial is 2 times 3 times 1, so 6. 4 factorial, look at that, 4 factorial would just be this. So 4 times 3 times 2, so 24. And we just found 5 factorial to be 120. 6 factorial is just 6 times that 120. So that's 720. And those are the ones you probably will be able to recall pretty quickly as to what they are. Anything higher than that, you might want to grab your calculators. So what is 53 factorial? Well, we're going to write it like this. 53 times 52 times 51 times, and then we're going to go ... and we're going to show 3, 2, 1. So we can actually display 53 factorial like this, as the number of actually multiplying all of those together is really, really, really large. All right, so what about this one? It's algebraic. What about 4n plus 1 factorial? Well, we would start with 4n plus 1, and then we would subtract. Now, we want to use parentheses to represent each number in this problem. So then I'd have 4n, because that would be 1 less than that. And then that would be 4n minus 1. And you could write 4n minus 2, and so on, down to 3, 2, 1. And that's how we could display 4n plus 1 factorial. All right, let's go ahead to some more examples. I wrote them somewhere. Where did I write them? Here they are. All right, so we're going to go ahead and simplify these. So what we have to know is that simplifying factorials is not like simplifying the number 8 over 6, because it is the product of 8, 7, 6, 5, 4, 3, 2, 1. And 6 factorial is not just the number 6. It is 6 times 5 times 4 times 3 times 2 times 1, and so on. So we cannot just reduce a fraction and think, oh, I'll just take the factorial of that. That's not going to work. But what we can recognize is that 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That when I write 6 factorial underneath of that, all of those would simplify. So we can recognize that 8 times 7 times 6 factorial over 6 factorial, because this is 6 factorial, we would just be able to reduce that part, leaving only 8 times 7. Excuse me. So let's take a look at this one. Now this is 5 factorial, which is 5, 4, 3, 2, 1, times 5, 4, 3, 2, 1, right? Like we have all of that. And that's over 100. So maybe for this, we would simplify it by simply just finding ways of reducing this. So maybe you just want to do 5 and 2, and 5 and 2. Now that's 10 times 10. Well, that reduces with your entire 100, leaving you 4 times 3 times 1 and 4 times 3 times 1. So this turns out to be 12 times 12, or 144. So just use a little bit of clever reducing, and it works out really cool. Now, what about something like number 3? we could start by saying, okay, I have 4 factorial and 5 factorial in numerator, and in the denominator I have 6 factorial, which is really 6 times 5 factorial. So that entirety of that 5 factorial would reduce, because 6 is made up of 6 times 5 times 4, 3, 2, 1. Well, the 5 factorial is already in the numerator. So now I have 4 times 3 times 2 times 1 over 6, because all that's left is the 6 from that 6 factorial. And then I can do another bit of clever reducing, and this final result is just 4. All right, how about 17 factorial over 19 factorial? Now, before I start explaining it, I want you to think of number 1. Take a look back at number 1 on the screen. If I can expand the larger one to include the factorial of the smaller one, we can do that here as well. So 7 factorial, being the smaller one, is going to be included kind of like it's a piece of the larger one, right? So then these two would cancel, leaving you just 19 times 18. And if you're not sure what that is, of course we can grab our calculators. 19 times 18. So this would be 1 over 342. All right, and finally, let's take a look at a couple algebraic. I got 4 examples here. Let's start with these 2. So just like we were able to expand and see what happens with them numerically, we can also do this algebraically. So if n plus 3 factorial means n plus 3 times n plus 2 times n plus 1 times n minus 1 dot 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 all the way down to 321. Well, if my denominator is n plus 1 times n minus 1, wouldn't all of that be wiped out? So it's like the smaller one is included in the larger one, and you really only have to look at the factors, the numbers that are different. So this one actually simplifies to n plus 3 times n plus 2, which could also be written as it would be multiplied out as n squared plus 5n plus 6. So that's a simplified form. The same thing is going to happen for this next one, except we notice the larger one's on the denominator. So n plus 1 factorial can stay, and n plus 2 times n plus 1 factorial, because that is built within, that these would actually be the same and be able to be canceled, leaving a final answer of 1 over n plus 2. Okay, so let's take a look. Number 3. Which one is larger? Which one has the other one embedded into it? It's the denominator. So n minus 2 factorial can stay, whereas the top would be n times n minus 1 times n minus 2 factorial. So that is going to simplify to just 1 over n squared minus n. Final answer. Same thing. Which one's bigger here? Well, the bigger one's the 3n, because you'd have 3n minus 1, 3n minus 2. Oh, and that's where it would start picking up and repeating. So this would be 3n times 3n minus 1 times 3n minus 2, and that's where the dot, dot, dot would begin, where we would start continuing to go down. Our factorial actually starts right there. So this 3n minus 2 factorial can actually cancel with all of this right there, leaving the algebraic expression of 9n squared minus 3n. All right, so I want you guys to work together and finish up that worksheet, and we can go over the answers on Monday, and this just kind of kicks off our last little mini unit. You will see some of these types of problems on the final for simplifying and things like that, and I just want to make sure you guys are prepared. Not to mention it will show up in some of your calculus curriculum over the next 2 years. So have a great weekend, you guys, and I will see you on Monday.